Hi all. So in this video we are going to learn the conversion of flip-flops. That is, how can we convert one flip-flop into another one. To convert one type of flip-flop into another type, we have to obtain the expressions for the inputs of the existing flip-flop in terms of the inputs of the required flip-flop. Suppose if you want to convert our SR flip-flop into JK flip-flop, that is available flip-flop is SR. If we want to convert it into JK, then we have to obtain the expression for the input of the SR flip-flop in terms of the input of the JK flip-flop. Okay, so that's the procedure. So we can convert one flip-flop into another one by using some combinational circuits. Combinational circuit is nothing but a large circuit. It is mainly based on some AND gates or OR gates like that. So this is the basic block diagram of the conversion procedure. So this is the input of the required flip-flop. Okay, that is, if you want to convert SR into JK flip-flop, so the input will be J and K. So here some common circuit will be there, some AND gate, NOT gate will be there, and this is our actual flop, that is our SR flip-flop will be here. Okay, and we will get the output of the required flip-flop here, that is the output of our JK flip-flop here. So this is the normal block diagram of the conversion procedure. Okay, and now we are going to convert the SR flip-flop into the JK flip-flop. How can we convert the SR into the JK flip-flop? Okay, and for that we know that the available flop is SR, and we have to obtain the expression for this S and R in terms of this J and K. So that's our procedure. Okay, so for that we must know the truth table of JK flip-flop and the excitation table of SR flip-flop. So here we are converting SR into JK, right? Okay, so for that we must know the truth table of JK flip-flop and also the excitation table of an SR flip-flop. The excitation table, we have already learned the excitation table. Just have a look of the excitation table of SR flip-flop. That is for 0 0 the required inputs are 0 X, then for 0 1 1 0 1 0 0 1 1 1 x 0. So we must know this excitation table very well. Okay, and this is the design procedure. So in the first column we have to write the external input. Okay, that is we are converting SR into JK, so the external input will be JK. Okay, and here J and K will be the variable, and another one more variable will be there, that is present state of the flip-flop. We are considering it as the third variable. Okay, so three variables will be there, J, K and Qn. Okay, and for the three variables we are writing the possible combination. That is, we know that for three variables we are writing 0 0 0 0 0 1 0 1 0 0 1 1 up to 1 1 1 like that. Okay, so that's the first step. So here we are writing the external input and the present state of the flip-flop. Okay, so we are treating it as three variables. J, K, Q, N are the three variables, and the corresponding combinations are 0 0 0 to 1 1 1. We are writing 0 0 0 to 1 1 1 here. Okay, and after that we have to write the next state of the flip-flop, that is JK flip-flop. Okay, we know that for a JK flip-flop, for 0 0, if the present output is 0, the next output will also be 0. That is, we know the truth table of JK flip-flop. That is for 0 0 condition, no change condition is there. So the output of the flip-flop will continue as 0. And for if the present output of the flip-flop is 1, and also for 0 0 here present output of the flip-flop is 1, then the next output always will be 1. Okay, that is no change condition is also applicable here. And for next case, for 0 1, we know that the present output is 0. Okay, and also we know that the next state also will be 0. and for the next case 0 1, the present state is 1, and we know that according to the truth table, when j is equal to 0 and k is equal to 1, the output will be always be 0. Okay, and like that we are writing all these qn plus 1 values here. Okay, that is based on the truth table of j k flip flop, we are writing the output here. Okay, and based on this present and the next state, we have to write the excitation table of SR flip flop here. Okay, this is the present state and this is the next state, and based on these conditions we have to write the input S and R here. Okay, and we know that for 0 0 condition, if the present state is 0, if we want to keep that 0, we have to apply SS 0 and RS X. Okay, X means R can be 0 or 1. Okay, that we have already learned the video of excitation tables. And for 1 1 also, we know that S is X and R is 0. And for 0 0, next condition is 0 0. For 0 0 condition, we know that S is 0 and R is X. For 1 0 condition, we know that based on the excitation table of SR flop, for 1 0, if the present state is 1, if we want to change that into 0. Okay, 1 0 condition, the input of the S and R should be, inputs S and R should be 0 and 1. So like that we are writing all other conditions here. Okay, and after that we have to draw the K-map for S and R. That is, we want to obtain the expressions for S and R in terms of this J and K. Okay, that's our procedure, that's our condition. Okay, so we have to draw the K-map for S as well as the K-map for R. So first we are drawing the K-map for S. This is the K-map for S. Okay, the variables are J, K, Qn. Okay, J, K, Qn are the variables, and based on these values we are putting the values of S in the corresponding cells, that is 0 x 0 0, 0 x 0 0, and 1 x 1 0, that is 1 x 1 0. Okay, and also after that we are drawing the K-map for R. This is the K-map for R. Based on the corresponding inputs, we are writing the corresponding values of R in the cells. Okay, and after that we have to group the ones here. Okay, we are going to group that is, we are going to find the expression for S. Okay, so for that we have to group the one. Okay, only the pair combination is possible here, that is 1 and 1 can be grouped. Okay, so from this the expression for this group, that is the pair expression for this pair will be, we know that is J Qn bar. So S will be equal to J Qn bar, and from this truth table the pair is here, and for the expression for R will be R is equal to K Qn. Okay, so here we obtain the expression for S and R in terms of J and K. Okay, and we have to draw the corresponding diagram. So the available flop is SR. So here we are drawing the figure of an SR flip flop, and we know that S is equal to J Qn bar. Okay, J Qn bar. So J is the external input here, Qn bar. Qn bar is the corresponding output of the flip flop. Qn is the output, Qn bar is the entirely opposite output. So J Qn bar. So Qn bar is taken outside from here, and we are using an AND gate for getting J Qn bar at the output of this AND gate. Okay, so S is equal to J Qn bar, and we know that R is equal to K Qn. Okay, R is equal to K Qn. K is the available external input, and Qn here we are taking Qn here, and using an AND gate we are producing K Qn. Okay, so we have converted an SR flop into JK flip flop. So this is a simple procedure. Okay, so for converting one flop into another flip flop, we must know the excitation table of the available flip flop and also the truth table of the required flip flop. Okay, another example is that is JK to SR. Okay, JK to SR. For that we have to write the truth table first, the entire table first. So we know that for an SR flop, the conditions are 0 0 0 1 1 0. 1 1 condition is not there in SR flop. Okay, 1 1 condition is not there in SR flop, and corresponding Qn, the present output is treated as, that is, first we are writing 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1, and 1 1 0 condition is not there. Okay, 1 1, we can't write 1 1 0 1 1 1 like that, because this 1 1 condition is not there for an SR flip-flop. Okay, and after that we are writing the Qn plus 1 based on the truth table of SR. We know that for 0 0 the output Qn plus 1 will be 0, for 0 0 output Qn plus 1 will be 1, for 0 1 Qn plus 1 will be 0, for 0 1 Qn plus 1 will be 0, for 1 0 Qn plus 1 will be 1, for 1 0 Qn plus 1 will be 1. Okay, based on this two columns we are writing the excitation table of JK, that is, for, we know that for 0 0 0x 1 1 x 0 like that. Okay, and after that we are drawing the K map for J and K. Okay, and here for the case 1 1 0 and 1 1 1, okay, 1 1 0 and 1 1 1, we are treating it as don't care. Okay, we are treating as don't care, so 1 1 0 we are putting x here. Okay, only the values up to 1 0 1 is there in our table. Okay, so after this 1 0 1 we know that two more combinations are there, 1 1 0 and 1 1 1. Okay, so it is not there in SR flow, but still we are considering it as a don't care condition. So here we are writing for 1 1 0 we are writing x, for 1 1 1 also we are writing x. Okay, and after that we are drawing the gamma for K. Okay, after that we are going to group. Okay, so here only one is there, another three don't care conditions are there. So by grouping this we obtain J is equal to S, and also here we can group this one along with three other don't care conditions. Okay, so the expression for K is equal to R. So for converting this JK into SR, we can simply directly give the external input S to J and also the external input R to K. Okay, that's the conversion of a JK to SR flip-flop. So the conversion procedure is very simple. You have to learn well the excitation table and truth table of every flip-flops well. Thank you.